So if you have made it to this vodcast, you have spent a lot of time working on T-charts and figuring out how to set those up, but none of your T-charts have been particularly science yet. And so now it is time to take two great tastes and put them together. We are going to take moles, which we touched on very briefly earlier, and we are going to combine it with T-charts. So I have two problems here that I'm going to do with you, and then I'm going to turn you loose to work on the rest of the packet. So you can see up here at the top, let's look at this problem. You use 0.72 grams of chalk, or CaCO3, to write chemistry rules on the sidewalk outside of UPrep. How many moles of chalk is this? Okay, so the first thing is that you are going to need to get your calculator out, and you're also going to need a periodic table handy. So hopefully one of those is not too far away. Grab that. The first thing you'll see here is I give you kind of some structure to this problem. You will not have to do these steps every time, but since this is brand new, I'm going to walk you through kind of this little benchmark. The first thing you see here is I ask for the molar mass of CaCO3, and you might be going, oh, molar mass, is that what? Is that? I want to show you, remember this chart? It was on a totally different note sheet called molar mass notes back when you were first introduced to the idea of moles, and there were these numbers over here. The key is you need to remember where those come from on the periodic table. These are the numbers that we used to refer to, and still can refer to, as atomic weight or atomic mass. These numbers are now, well, not this one specifically, but these numbers are now molar mass. It's how much 1 mole of something weighs. 1 mole of aluminum is 27 grams. 1 mole of that's magnesium fluoride is 62.3 grams. These numbers, like I said, we find them on the table. So let's go back here. How would we find it for calcium carbonate is what that is, CaCO3. We look on the table and find calcium, 40.08 grams, plus carbon, 12.01 grams, plus 16.00 times 3. So calculator's out. Let's fire that up. 40.08 plus 12.01 plus 16.00 times 3. And we get an answer of 100.09. And I know that's good because we're adding, right? Remember Sig Figs? Those aren't going away. We have 2 Sig Figs, 2 digits after the decimal. So my answer can have 2 after the decimal because that's the adding subtracting rule. So bring it down to the equivalent statement. Remember, equivalent statements are things like 1 day equals 24 hours. Well, now we know we can say that 1 mole of calcium carbonate will weigh 100.09 grams. Just like kind of on over here, we can say that 1 mole of magnesium fluoride weighs 62.3 grams. Conversion factors. This is also not something that I will ask for every time, but you should be able to write them kind of on command. So I'm going to take this statement right up here, where 1 mole equals 100.09 grams, and turn it into conversion factors. Remember, those are kind of those little fractions. And for every equivalent statement, we get 2 possible conversion factors, kind of the fraction and then its reciprocal. So I can say 1 mole on the top. And if you'll notice, I didn't put an E there. That's the super fancy abbreviation for the word mole, is you just take off the last letter. I know it's kind of goofy. And then the other conversion factor would be the opposite, 100.09 grams on the top and 1 mole on the bottom. So now let's go down. So all this is kind of pre-work, and eventually I will not ask you to show me this because you will do all of this in your head. But until that happens, I want to kind of walk you through it step by step. Now we're actually down to the part where we're going to solve the problem. So here we go. Let's go back up here. Remember, one of the things that is hopefully well ingrained in your brain by now is that the number that we start with in the problem is the number that goes in the top right of our T-chart. 0.72 grams. And remember, it is a quarter point off every time one of these numbers goes without its unit. So we're putting grams in there because this is going to help us figure out which of these is going to be useful in our T-chart? Are we going to want grams on the bottom and moles on the top, or grams on the top and moles on the bottom? Hopefully you said grams on the bottom so that grams cancel out. 1 mole up on the top. And then calculators on, 0.72 divided by 100, 0.09. We used, our calculator says 0.0071935, and hopefully you're saying, what about Sig Figs? Oh, I'm so glad you asked. We have 0.00, because remember these aren't going to count. And looking here, this number is infinite. 1 mole, that's going to be an infinite number because we actually kind of decided upon that as being a counting number. But I have 5 Sig Figs here, 2 Sig Figs here, which means I can keep 2 in my final answer. I'm going to put a unit on my final answer so I don't lose a quarter point on the test. There we go. Okay, let's go on to the next one. We're going to set up another equivalent statement and conversion factor so that you can figure out how many particles. Now we're going into particles. If you're going, oh my gosh, I don't remember that. Remember this, go back over here when in doubt. Remember that 1 mole of something is going to have 6.02 times 10 to the 23rd particles. And that is true regardless of what that thing is. You can have a mole of goldfish, a mole of donuts, or a mole of atoms, and you will always have the same number. So let's pop down here. We have 1 mole of calcium carbonate is how many grams? Well, we already figured that out up here. We know that 1 mole weighs 100.09 grams. 1 mole of anything is how many particles? 6.02 times 10 to the 23rd. Remember that for this second statement, the CaCO3 part is totally irrelevant. It doesn't matter that it's CaCO3. It just matters that we have 1 mole of something. Okay, so now we're starting in grams, but instead of going from grams into moles, we want to go from grams into particles. So our T-chart setup will look very familiar. But now you recognize this format where it's getting a little longer. So I'm not going to write the conversion factors this time. Now I'm going to start to ask us to do that kind of in your head. So let's take a look. We have 72 grams. We want to use this first unit to get us out of grams and into something else. This top equivalent statement will help us because this is the only one that has grams in it. Do grams go on the bottom or the top? They'll go on the bottom, so grams cancel out. Put your unit so you don't lose a quarter point. 1 mole up on the top. Now the very last piece is we want to get into particles. So let's look at this statement down here. We have particles on one side, mole on the other, and we need to choose which one's going to go where. It's going to be 1 mole on the top and 6.02 times 10 to the 23rd particles on the bottom, or the reverse. Hopefully you should see that 1 mole is going to go on the bottom so that we can put 6.02 times 10 to the 23rd particles up on the top. If it makes your nerd heart happy, feel free to cross out units. I like that part. Crossing out units that show up more than once. Plug it into your calculator. So we have 0.72 times 6.02 times 10 to the 23rd. Divide that answer by 100.09. 4.33050 blah 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 times 10 to the 21st particles. Let's do Sig Figs really quick. Same thing. These numbers that I'm circling will all have infinite Sig Figs, so we're looking here and here. This number has 2 Sig Figs. This number has 5. My answer can have 2. 4.3 times 10 to the 21st particles. So with that, go on, do the rest of the packet. Good luck, have fun.